Hello there. So today we are going to solve another LeetCode problem named power of x to n. Basically, we are going to implement our own solution to putting any double value x to the power of integer n. There are some constraints. The most important one is that n is actually could be negative. And that's it. So let's start. I think that first of all, let's check our inputs for some edge cases, starting with the value of n. Obviously, if the n is equal to 0, then any value in the power of 0 is going to be 1. And any value in the power of 1 is going to be the value itself. And also, if the power is -1, we are going to return 1 divided by this value. Cool. Let's check for x now. First, if x is equal to 1, then the result is going to be 1 in any case. And if it is -1, then it depends. If n is going to be even, then the result is going to be 1. Otherwise, the result is going to be -1. Finally, we need to implement the general solution for all the other cases. So let's start. First of all, let's create a buffer for our result and put the x there. And then the most obvious solution would be to iterate from 1 to n-1 and multiply the result by x. Finally, we would return the result. The only problem is that n could be negative, right? In this case, our cycle is not going to even start. So how could we solve it? Let's create the absolute value of n and calculate this. And now we're able to use it in our cycle. Now, if n is greater than 0, then we are going to return the result. Otherwise, we are going to return 1 divided by our result. And this is the most simplest solution. So let's check if it works on our small test cases. It does. Yeah. The only problem is the runtime. It takes almost 2 seconds for these 4 test cases, which is not really good. So how could we optimize this code? Well, let's check. If we are multiplying x by x by x and so on and so forth, the most obvious solution to get the result faster is actually to multiply the greater values. In this case, we would have much less computations. However, we do need some sub-results to do all these calculations. So, for example, if we are going to multiply the result by itself, then what kind of sequence of values we would find in the result after each iteration. So if we are multiplying the x in the power of m by itself, then the result is going to be xa in the power of 2m. Yeah? So the values which we would find in the result after each step would be first the power of 1, then the power of 2, then the power of 4, the power of 8, and so on and so forth. And the most important thing is that if we would have something out of this set, like the power of 7, we could always use our previous sub-results. For example, the 7 is the sum of 4 plus 2 plus 1. So we can multiply the x in the power of 4 to the x in the power of 2 to the x in the power of 1 and get our result. All right? So let's remove this code and start from the scratch. So we need to calculate all the sub-results to some kind of great possible power for this particular n. Let's start from the power of 1 and mark the greatest power as our current power. Let's create our sub-result, which is going to be x. And also let's create the sub-results dictionary, which is going to contain values for all the calculated powers. Initially it's going to be empty. Finally, let's start our calculations. So while our power is less or equal of n, of absolute value of n, we are going to actually use this power. So we are going to record the sub-result to our dictionary. Also, we are going to mark the greatest power with the new value, and then we are going to prepare the next sub-result for the next iteration, which means we are going to multiply it by itself, and it also means that the power is going to be doubled for this case. Cool. So now we have all the sub-results for the all the powers of 2, and we could start our computations. So let's start from the greatest one, which we have. So the sub-results dictionary is not empty, and we are sure that the greatest power is there, so because of that we could use the force unwrap. So what is the rest of n which we would need to multiply? It is the absolute value of n minus greatest power. For our small test case, for the power of 7, we would have the greatest power of 4, and the rest is 3. So we still need to multiply the result by the power of 3 to get there. So while our rest of n is greater than 0, we are going to continue our multiplications. So at each particular step, we need to find the greatest possible power to fit in to the rest of n. For example, in our previous case, the power of 7, if the rest of n is 3, we are not able to use the power of 4, but we are able to use the power of 2. So while the power is greater than the rest of n, we are going to just divide it by 2. Right? And finally, we are able to use these sub-results and we could remove this power from the rest of n. Great. The only thing which we could do even better is to change our greatest power, because at each particular step we are not going to use the power greater that at previous step. So let's assign the greatest power to our current power. And I guess this is it. Let's check for any compilation problems. Oh yeah. Great, it works. The runtime is absolutely amazing. So let's submit and check it for all the other test cases. Yeah, so it takes 1 millisecond, 0 milliseconds. Basically, it stays on the edge of the threshold and beats almost every other solution. So if you'd like to see me solving any other LeetCode problems, please put your request to the comment sections, and cheers!